Here we have a pair of equations. One of them is quadratic and one is linear. So what we're going to do in this video, I'm going to solve it manually, and then we're going to also plot it on a graph, and we are going to examine some of the features on the graph as well. So let's write the equation here. So we have x squared plus 8y equals 13. So we have x squared plus 8y equals 13. And we have x plus 2y equals 2. Let's label the first equation as A and this one as B. From equation B, we can find the value of x by taking 2y both sides. Therefore, we have x equals to 2 minus 2y. Let us label this equation B1 since it is formed from B. What we're going to do now, we're going to substitute equation B1 in A. So let me write the statement so that you can remember that. So substitute x equals 2 minus 2y in equation A. Therefore, from equation A we have x squared, but we know that x is 2 minus 2y, so we're going to have 2 minus 2y squared plus 8y, that's 8y, and that equals 13. Let's expand and simplify. Two times 2, that would be 4. Minus 2y times 2, that's minus 4y. And also minus 2y times 2, that's not minus 4y. And so we add them together, so that's minus 8y. Then minus 2y times a minus 2y gives us a positive 4y squared plus 8y equals 13. Minus 8y and positive 8y there, that would become 0. Let us take 4 both sides. So we would have on the right hand side, we take 4 from 13, that's 9. So now we have 4y squared equals 9. We divide both sides by 4 to have y squared on the left hand side. So we need to get y, so we take the square root both sides, so the square root of 9 over 4 there, that would be plus or minus positive 3 over 2. Okay, so we have two values for y. So when y equals 3 over 2, we can get x from equation B1. So from B1, we know that x equals to 2 minus 2y, and we got the value for y, which is 3 over 2. These two can cancel out, so what we have there is 2 minus 3, and that's just minus 1. So we have gotten one solution for one of the coordinates there, so we would have the x value, which is minus 1, and the y value is 3 over 2, which is 1.5. So that's the first solution for the equation. Let's just highlight that. So that's the first solution there, minus 1 and 1.5. Now when y is minus 3 over 2, let's work that out now. Y equals minus 3 over 2. From B1 up here, we know that x equals to 2 minus 2y, and now y is negative 3 over 2. So that would cancel out. So minus and minus there would be plus. So we have 2 plus 3, and that's 5. So the next solution of the equation then would be 5 for x, and y is minus 1.5. So we have solved the equation. So what we're going to do now is to plot the graphs. We're going to discuss some features of it. So let's plot the graph. So we have x squared plus 8y equals 13. So equation A, the graph for equation A is the parabola that we have here. Okay, now let's plot the equation for B, which is x plus 2y equals 2. Okay, so x plus 2y equals 2 is this one, so I can label them now. So this graph here is x plus 2y equals 2, and that's a straight line graph. And the graph of the parabola is x squared plus 8y equals 13. Now let's look at the point of intersection on the graph. So where the graph meets here, both graph meet, is we have one of the solution, which is -1 and 1.5, which is consistent with our solution there. So let's just label this, let's circle this. So that's one of the solution, and that is consistent with what we have done in our calculation. Now let's look at the other point of intersection here. That's 5 and -1.5. That is also consistent with our calculation as well. So that's positive 5 and -1.5. So when we solve these equations, they are not in isolation. It's the point of intersection of the parabola and the straight line that gives us these solutions. Now, just need to look at two more things before we wrap it up. Now, if we should rearrange this equation so that y, everything is equal to y, we can discuss a few features. So let's write the equation here. We have x squared, that's equation A, plus 8y equals 13. Let us make y the subject of the formula. So we subtract x squared both sides. So we would have 13 minus x squared. Let us divide throughout the equation by 8. Therefore, we have y is equal to 13 over 8. And 1. So I want you to know that this value here, 13 over 8, is where the graph of the parabola cuts the y-axis. So this point here where it cuts the y-axis is 13 over 8. And also we could look at the solution when y is equal to 0. When y is equal to 0 here, we have x squared equals 13. X squared equals 13. So it means that the solution of the graph would be plus or minus the square root of 13, plus or minus root of 13. So where it cuts the x-axis here, that's the root of 13, positive root of 13, and on the negative side over here where it cuts it, that would be negative 13, root of 13. Okay, so also when the coefficient of x squared is negative, the graph has the N shape, or you can see that it's like an N, so you could identify that as well. Now let us look at the linear graph, which is x plus 2y equals 2. For that graph we have x plus 2y equals 2. If we should make y the subject of the formula, it means that we take x both sides. Therefore we'd have 2y equals to 2 minus x. We divide throughout by 2, so we have y is equal to 1 minus a half x. Here, this value 1 is where the graph cuts the y-axis as well, the straight line graph. So here, this point is where it cuts the y-axis, which is at 1, which is consistent with it as well. And then the gradient m on the graph here, if we just look at this right angle triangle here, which is this one here, this little one here, the gradient is a change in y. The change in y there is one unit, and because it's sloping downwards, it's going to be a negative, and the change in x is 2 units. Therefore, the gradient is minus 1 over 2, which is consistent with what you got there. Thank you very much. I hope this really helps. But this is one linear and one quadratic, or simultaneous quadratic equation, and that's how you solve it. Thank you.